Okay, carbon dioxide. I just want to point out one thing. At one point, there was very little oxygen there was no oxygen in the atmosphere. Oxygen only showed up after there were plants and cyanobacteria that use chloroplasts or that use photosynthesis. And of course, with photosynthesis, one of the products is oxygen. And then the consumers, the allotrophs, uh, like herbivores and things like that, they actually breathe the oxygen for oxidative reduction. And then they expel as a waste product CO2. Okay. Now, a lot of carbon gets locked up in organic compounds. As an example, in the Arctic, there's these kind of tundra that get frozen. And if the tundra gets unfrozen, there's a whole bunch of decomposers, and part of the decomposition process is the release of carbon dioxide. So, carbon dioxide, there's a long history that geologists have been able to read, showing there's a positive relationship between worldwide temperatures and level of carbon dioxide. Carbon dioxide, furthermore, when it's at a very high level, also acidifies the oceans as well. So there are a number of reasons why there's carbon dioxide. In the past, it was all natural reasons. In addition to, volcanoes released a whole lot of stuff, including carbon dioxide. And, but the question is now, we have a huge expansion of the amount of carbon dioxide in the atmosphere in the last 100 years that coincides with the Industrial Revolution, actually more than 100 years, a couple of 100 years. But obviously the population was much smaller a couple of 100 years ago than it is now. And the technology is much more complex now and requires a lot more energy. So as you know, photosynthesis takes carbon. Let me see. And, okay, carbon dioxide, and along with water, produces a carbohydrate which has a lot of stored energy in all these carbon-hydrogen bonds, and then oxygen. Now, so that normally locks up a lot of carbon dioxide. The trouble is, one thing that reduces the amount of carbon dioxide is when, let's say, you have trees that are cut down, trees that would normally take in carbon dioxide as part of the photosynthetic process are no longer a carbon sink. In other words, where you can actually store carbon, so it's actually not in the atmosphere. It creates a CO2 sink. But deforestation decreases that sink. Now, furthermore, when you burn these carbohydrates, these long carbon-hydrogen chains and oxygen chains with oxygen, you get 6 CO2s, 6 H2Os, and a lot of energy. But burning hydrocarbons, and hydrocarbons are fossil fuels, you end up This is the equation. And you also get a CO2 and H2O. Okay. Now, hydrocarbons actually have the most energy stored per unit volume, except for forgetting about radioactive decay. Okay, now these things, hydrocarbons like coal, oil, natural gas, all these things are ancient sources of carbon that have been sequestered. The thing is, when you actually burn them, this is oxidative, so you're using O2, you're releasing large amounts of carbon dioxide. And so that's what is actually probably causing the increase in carbon dioxide in the atmosphere. Furthermore, carbon comes in different isotopes, especially depending on how it's turned into, let's say, carbohydrates, or from going from carbohydrates to carbon dioxide. And so a lot of times you can figure out where the carbon came from by looking at various isotopes. So there's C12 is the most normal isotope, 12 protons. But there's also carbon-14 and carbon-13 as well. And the kind of isotope of carbon that we're seeing now is most closely associated with burning fossil fuels. Now, there's something called the greenhouse effect. Sun's rays, of course, hit the Earth. Heat normally escapes, especially, let's say, if you have a bright surface like snow or ice, right? A lot of the energy is bounced back off into space. Dark objects, though, receive sunlight and then hold that energy in. So you might know this because let's say you go outside and you've got a black jacket on. Well, first of all, the jacket is going to hold in heat, but also if you had let's say a white parka versus a dark parka on, in one you would get stay much warmer than the other. Okay. Now, besides CO2, there are other gases that are that were produced by biotic environments, including methane and nitrous oxide. Okay? Now, what happens is greenhouse gases like CO2 and methane are in the atmosphere, and they actually stop the sun's rays and the energy from escaping out into the atmosphere and then off into space. And so the temperature increases, and there's some, if you look at Venus, Venus is like 900 degrees. Of course, it's quite a bit closer to the sun, but it's got this huge, thick atmosphere of carbon dioxide and other things that trap gases. And so basically it can't shed the heat that our planet can do. Okay. Now, first of all, there's a big debate about whether human beings are responsible for climate change. Climate change happens naturally because of cycles. Sometimes the Earth's orbit around the sun is actually further out from the sun compared to other times. It's called a Milankovitch cycle. You don't have to know that. But the ones that are farther out, they coincide with ice ages. So they're getting less solar energy onto the Earth. Um, there have been times, like during the Mesozoic and the dinosaurs, when the Earth was a very warm place. In fact, places like, uh, let's see, the Arctic region and the Antarctic nowadays are, of course, very cold. Well, they were almost, they were temperate. Didn't get all that much snow. There were no, there was very little sea ice. So you had water that was soaking in, because of its darker color, more energy. And it stayed that way for quite a long time. Okay, now, so climate change is a natural cycle. Um, Climate change is sometimes influenced, let's say, by large amounts of volcanic activity, really huge amounts. The Siberian traps, about 250 million years ago, in fact, looks like it created the largest mass extinction the Earth has ever seen, even bigger than the asteroid strike. And it poured lots of stuff in the atmosphere, including sulfur dioxide and things like that. Okay. And at that time, level of oxygen actually went down. It also increased CO2 levels. And so the oceans actually turned very acidic. Okay. So global climate change is part of a natural cycle. The question is now, are we influencing climate change, including global warming because of the greenhouse effect, because of the burning of fossil fuels that spew large amounts of CO2 into the atmosphere? And that CO2 tends to stay there for quite a long time. And as I mentioned, some of the evidence suggests that there's isotopes of carbon that, in terms of CO2, that are more common from burning fossil fuels than from other reasons. Okay, like animals breaking down food, they release oxygen. No, they release carbon dioxide. Okay, so furthermore, as more energy is retained in the atmosphere, water temperatures increase as well, and water has a property of high specific heat, so it holds on to energy much more readily than, let's say, something like a cast iron frying pan. If you heat water to, let's say, 100 degrees or 90 degrees centigrade, and a cast iron frying pan to 90 degrees centigrade, the water will take longer to equilibrate with the temperature around it than the cast iron frying pan, which it gains heat very quickly, and it loses it very quickly. Now, in terms of global warming, most animals and plants are adapted to specific temperature ranges. This is the abiotic environment, or one of the drivers of the abiotic environment. Another is amount of water available in the atmosphere and on land as either a liquid or a solid. Okay, so obviously, not just animals but plants. You're going to find certain plants and animals in certain places and not others. Like polar bears, you're going to find in the Arctic. And they're normally going to spend a lot of their time during winter out on the ice floes hunting seals. But because of global warming, which is in fact has been measured, we are showing higher temperatures than we've had for the last, many thousands of years. Okay? So, polar bears, of course, can't go anywhere colder. So a lot of them are actually spending less on the sea ice and more on land, but their main food source is normally seals, and they're not getting it. Okay. When there's higher CO2, the CO2 also goes into the ocean and acidifies it. So that affects a lot of things. Now, let's say you have a mountain range, and as you go higher, it generally gets colder. So there's a lot of things that, if it gets warmer, plants and animals can move upslope to a higher elevation. But there's a limit to that. And so we might see broad shifts in the ranges of plants and animals. And then finally, with global temperature change, and in this case warming, caused by human burning of fossil fuels. And there's, of course, a big debate, but there's really not a debate. Most of the people who say it's not happening are not scientists, or if they are, they've been bought. They're scientists that are working for the oil companies or things like that. Okay, so the consensus right now is that higher temperatures are due to global warming caused by man. Now, as I mentioned, in the Arctic, normally during the wintertime, there's a large amount of sea ice that is basically, the whole thing is ice. Well, if that sea ice melts, it's already on the ocean, so that's okay. But if you have large glaciers that are on the land that melt, you're adding liquid water into the oceans and elsewhere. So the two biggest ice sheets on the planet are Greenland, which is the biggest island. The whole thing is covered by this huge glacier. And then Antarctica, which is a continent, right? Very cold continent. And it too has huge glaciers on it. Because they're both in the Arctic. Greenland is up near the Arctic, is above the Arctic Circle, very cold. And Antarctica is very far south, near the Antarctic pole. Okay? So that causes sea levels to rise. We're actually already seeing that happen. If you actually look, if there's some sea islands in the South Pacific, like the Solomon Islands, some of the people living there have had to actually abandon a number of different islands because of coastal flooding. Now, it's really going to get much, much worse over time. The more the glaciers melt, the higher the sea level is actually going to rise. And it's thought that perhaps by the end of this century, 2100, the sea level might have risen by 50 feet or maybe more. That would mean places, all coastal areas around the planet would be affected. The ones especially that are on, let's say, flat plains next to it. So the southern Gulf Coast of the United States and part of the eastern seaboard would be completely flooded, and people wouldn't be able to live there anymore. So there'd be no Miami. There'd probably be no Houston. New York, there might not even be New York anymore because it would be underwater. Okay. Now, this is from 1960, and really from the 20th century on, the more fossil fuels we've burned. Before the 20th century, basically fossil fuel use wasn't even used before the 20th century. The more that's been burned, especially with increasing technology for energy generation and transportation, all that kind of stuff, has increased the CO2 level. And that CO2, by the way, has the signature of carbon that is released from the burning of fossil fuels. So, now there are yearly fluctuations, of course, in the CO2 level, but there's also, we see this increase all the way up. Okay, so like in the northern winter, there's more CO2 in the atmosphere than in the summer. Okay. There have been many instances in the past from the geological record and from either finding bubbles of what the atmosphere was like many millions of years ago, or using ice cores from glaciers to show that the amount of CO2 in the atmosphere was at times much higher than it is now, and that temperature always increased when that happened. Now, this graph actually shows on the x-axis years before the present. So over here we have the present. Here we have 400,000 years ago. Okay, y. Most of this is from atmosphere or air that was actually locked in glaciers in small bubbles. Okay. Now we can see there have been a wide degree of fluctuation. So on the x-axis, you can see degrees Celsius. 0 degrees is 2 degrees Fahrenheit, right? And then on the y-axis is the concentration of CO2 in parts per million. Okay? And you can see that temperature and carbon dioxide concentration fluctuate in tandem. When there's more carbon dioxide, there's more there's higher temperatures. Now this is a correlation, of course, and you might already remember that correlation is not a causation, and you might say, well, it could be temperatures actually causing higher concentrations of carbon dioxide, because plants can, and animals can, if things aren't releasing carbon dioxide when it's really cold, but when it is warm, it's warm all the time, they're always releasing carbon dioxide. But in this case, we have models that show cause and effect. Carbon dioxide goes up, temperatures go up because of that. Now, if we look, the last great ice age, global maximum was right here. And it's about 20,000 years ago. It was very cold. It was during the Ice Age. And in fact, there was much less concentration of CO2. These peaks right here are interglacial periods, okay, where it's warmer. Now, where obviously we were coming out of an interglacial period after this deep freeze about 18,000 years ago, which was the maximum in terms of temperature of coldness during the last ice age. The thing is, it is really in the very recent past, especially the 20th century and the last half of the 20th century, that carbon dioxide levels have really shot up. We see that right up here. In fact, we've never quite seen carbon dioxide levels that much in the last 400,000 years. and temperature is going up with it. Oh, and that's it. So, good luck. I'm going to post this, of course, and start studying for the final.